Hello and welcome to the Daily Space for today, August 6th, 2018. I'm your host for today, Dr. Pamela Gay, and I am here to put science in your brains. It's kind of a slow news day, but the news we have is pretty big and pretty awesome. It's not pretty photogenic, however. So, going to our first story, we have a tale of dark matter, not showing up in the correct place on the screen. Let's try that. Sorry, I changed my settings to try and get you guys better experience, and I appear to have screwed things up today. Thank you so much for your patience. So in today's first story, we have a tale coming to us from the Netherlands. One of their national scientists, they actually have a really cool national press office, astronomy.nl. One of their scientists has been working with a team on software they developed to try and understand if diffuse radiation that is seen in high energies in the center of our galaxy is being generated, as we often hoped, by dark matter. Thank you, Radio Geek, for the follow. That's awesome. Is being generated in the center of our galaxy by dark matter, as was hoped for, or if it might have more mundane explanations, like a whole bunch of neutron stars that were rotating very fast and giving off the radiation. Well, making it harder to find dark matter, we are finding this radiation is actually consistent with there being an appropriate number of neutron stars to match the general stellar population that we otherwise can see in our galaxy's central portion. So let me try and unpack that into English a little bit better for you. Several years ago, about 10 years ago, astronomers that were imaging the center of the Milky Way galaxy, the part in the box in this image, as they looked, they noticed that there was an excess of high energy radiation. This is radiation that can get created in a lot of different ways, from supernova explosions to our supermassive black hole in the center eating particles. But the distribution of this light wasn't consistent with any of the things that we were checking out at the time. And many dark matter researchers who have been hoping that dark matter collisions, interactions could, in highly dense regions, lead to dark matter annihilation that would be observable. This is that mythical way of how do you look at this thing that refuses to interact via the electromagnetic force. It has nothing to do with forming molecules. It has nothing to do with interacting with light. Photons and it do not get along. So it was really, really hoped maybe we were observing dark matter annihilation. But as the years have progressed, as our ability to do various simulations on high-power computers have progressed, both with advances in our software languages, advances in our hardware that we use to run those algorithms, it turns out that we now have a better understanding of if you see this many of this kind of star and this many of this kind of star, you should see this many of this kind of star. And when we try and look at the core of our Milky Way, a lot of stuff gets in our way. And I mean stuff quite literally. Dust, gas, stars blocking stars. With all of this interfering material, we're quite lucky that we are, in some wavelengths, able to image the stars going around the supermassive black hole at all. Now, since we can't get a full population distribution observation of the core of our galaxy, what we have to do is use our understanding of if this, then that, to build up models of, well, given what we see, we should also know that there are this many white dwarfs, there are this many little tiny red stars, there are this many neutron stars. And it's the neutron stars that are key. These neutron stars are highly dense environments. Interactions on their surface can lead to high energy particles being given off, especially when you have the axis of rotation and the axis of the magnetic field not aligned properly. I actually have somewhere in my desk a model that I put together that is perfect for this. But I cleaned my desk, so it wasn't exactly where I reached for. Now, this is not a neutron star. This is a model of a moon that has been highly damaged, and it's sticking on a stick. And we're going to pretend this is a neutron star, and what the toothpicks represent are the magnetic poles of this object. Now, as the pulsar rotates on its rotational axis, which is my fingers, it's rotating sometimes 1,000 times a second. It could be rotating once a second. Whatever it is, that's kind of a monumental rotation rate when you realize your neutron star is the size of Manhattan Island in diameter, not volume. And so you have something the size of Manhattan Island that is rotating extraordinarily rapidly with this magnetic field that is periodically pointed towards us. And when this occurs, we get a blast of particles that are traveling through that magnetic field, that are getting accelerated through that magnetic field. Now, some of those particles are going to end up interacting with the local media, creating, and by media here, I don't mean podcasters, with all that gas and dust and stuff that is preventing us from easily looking at the core of the galaxy. When these high energy interactions occur, radiation can get generated. High energy photons can get generated. And it's those interactions that models are now showing are probably responsible for all this excess radiation that isn't actually excess radiation. It's an underestimate of how much stuff is in the center of the galaxy. Unfortunately, while we can explain all the radiation with perfectly normal physics, with a better understanding of stellar populations, we still have no way to figure out how to detect dark matter. So one great story leads to sadness for many a dark matter researcher. Now, going on to today's next story, I bring you the Parker Solar Probe. Today, the instrument press releases and the hurry up and get ready to look information began coming out to members of the press who NASA knows may not prep a story more than a few days in advance. Now, it is hoped beyond hope that in 4 days, 14 hours, 35 minutes, and 31 seconds, the Parker Solar Probe is going to lift off on its journey to go where no actual spacecraft has gone before and plunge into the outer layers of the sun. This little mission is hoping that it will be safely able to traverse the sun's corona, getting us data we've never had before on exactly what are the densities, the particles, the temperatures, and how is this all evolving with the sun's magnetic field. Now, with this particular launch, it will be occurring during a fairly, not totally quiet, but fairly quiet period in the sun's life. But over the years that this solar probe will be out there, it will be able to track 1/2 of the sun's solar cycle, which means it will be able to track the sun going from the activity level that it's at now with the magnetic field alignment that it has now to seeing the opposite alignment. Now here I am once again going to use my popsicle sticks. In this case, I'm going to make the North Pole fluorescent pink because that's the pen I grabbed first. And as we look at now this is the sun, what we know about the sun is periodically the sun's magnetic field goes from being pointed north to being deeply chaotic to being pointed south. And as the pole realigns itself, what ends up happening is in the middle, as all the magnetic field lines are confused, we end up with magnetic field lines coming out the sides of the sun, and where the field lines emerge and go back into the surface of the sun is where we have magnificent sunspots. So hopefully, as Parker essentially watches the sun's field go from one orientation to chaos to the sun doesn't flip, the polar fields flip, to the other alignment, we will be able to understand all the different cool things going on. Now, that is pretty much our news for today. I am hoping that we will begin to see more and more information coming out, but it's possible that people are holding on to their results until the International Astronomical Union, which will start in just 2 weeks. So a week and a half from now, I'm going to be settling into an airplane and taking off via Chicago to head to Vienna, where I will be setting up as one of the people providing coverage of this meeting. I will be there as an officer of the International Astronomical Union and as the editor of this year's meeting's newspaper. So I will have all the hot tips for you and be able to let you know when everything goes live. So now I'm going to remind you that I will be taking your questions in just a moment. But before I do that, I have to give credit where credit is due. Here on CosmoQuest X on Twitch, we are brought to you by the Astronomical Society of the Pacific, working in collaboration with the Planetary Science Institute and Youngstown State University. Give us a follow so that you can find out when we go live. We bring you a variety of content ranging from, well, I will be coming on tomorrow night to systematically destroy the planet orbiting Kelt B in a really silly little animation that I'm working on. You can come back and stay for the daily space on Wednesdays and Fridays when directly following this, we have Dr. Matt coming on with Big J to, well, teach us some astronomy. Big J is a really good computer scientist who needs to learn some astronomy, and Dr. Matt is here to teach him and to teach you. We, of course, have the daily space every Monday through Friday at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. On Sundays at the exact same time, Annie Wilson from Young State University brings you a bit of planetarium magic. So give us a follow. Be part of everything that we do. And, we're sustained by you. Every subscription and every bit really counts. So thank you for being here. And I'm going to try and bring you this launch live, just to let you know. So stay tuned also for 4 days, 14 hours, 30 minutes, and 0 seconds from now as we watch the launch together. So now to take your questions. Working backwards through the chat, I see If all goes well, what max temperature will Parker face? I need to look up the temperature of the corona because it's always hotter than I remember. I'm really good with remembering concepts and really bad with remembering temperatures. So the corona rises from 6,000 degrees to a few million degrees. So we're looking at it, it's gonna experience like a million degrees. It has heat shields. It has really good heat shields. And the nice thing is the super hot material is super diffuse. So it's not like being in a room like we're in that has lots of air molecules constantly bouncing off your skin, preventing you from randomly bruising due to the vacuum of space. Where Parker is going, there's a very diffuse, close to vacuum thickness of material. Now, those molecules and atoms in the material are moving around with velocities, and temperature really corresponds to the energy of photons and the velocities of particles. Those particles are moving around, and those photons have a consistent spectra with these temperatures. But what we have to worry about is how many particles is hitting Parker at any one time, and can it defend itself against that small number of particles. So we're very grateful for the near vacuum of space. Hanny is asking, is that a TARDIS behind you? Yes, I have to admit, I'm in the process of doing some reorganization and threw a TARDIS blanket across my recliner, as you do. May the doctors always be there to help us. So Paranor is announcing that Tess caught a comet before starting science. That is cool. I am going to need to read that, and maybe I'll bring that to you tomorrow. There wasn't a press release on this one. Wow, those are messy images. Cool. Alrighty. Looking back, Hanny also asked, are there any extreme cosmological environments like neutron stars or black holes that could reveal dark matter if we get close for an observation? We have no idea at all. If someone says they have an idea, they are aiming to get a Nobel Prize when they're proven right. I, for one, am going to go with we have no idea. Scrolling back. Hanny, you have all the questions today. Could a larger version of the Kamiokande detector be used to search for dark matter? It's not necessarily that we need a larger detector, as we need to have the right fluids inside, and we need to have the most sensitive photomultipliers ever. There are ongoing efforts to update various of the detectors that we've used to detect neutrinos to also be sensitive for any possible indications of dark matter. And one of the things they're looking for with the Large Hadron Collider is to potentially generate dark matter that they are then able to detect in the detector. So we are looking for it in all the creative ways we can think of. It is just being determined. It's being very determined, not to be seen. Okay, going back down to the bottom. To see what questions I have missed. Okay, so Matt is taking this week off. So we won't be having we won't be having Astro 101 this week. Sorry for hyping something that doesn't exist this week. Okay. K Moore 101889 is asking, with the changing of the solar poles, does that mean that once we get some data, it can help shed some light on when the Earth changes its poles, or is it totally different? So the temptation is to say it's totally different, but the reality is physics works the same in identical situations, and there is a continual change as you go from one situation to another in a stepwise way. So while the Earth and the Sun are totally different in so many ways, magnetic fields are magnetic fields. They're governed by the same physics in every situation. And so what we have is a matter of scale. And the question is, will we get enough information that we are able to apply what is learned to the Earth? And we won't know until Parker Solar Probe starts sending back its amazing information, and we're able to backtrack to see, can this be applied to the situations like we have on Earth? Or is this like you can only detect relativity in relativistic situations and Newton's good enough everywhere else, and Earth is Newton and the Sun is relativity in this case? We need to find out, is this the kind of magnetic field that only works in this situation? We don't know. I'm kind of hoping that, as often happens, the data comes in and it is surprising and it is awesome, and it teaches us some new basic facts about how magnetic fields work. Let me pull up the solar corona information again. So at 500 kilometers above the photosphere, the corona is a few million degrees. I don't know the steepness at which it falls down, the temperature falls. I need to look up more. I will try and follow up on that for you. But it's going where no mission has gone before, and it's prepared for extraordinarily high temperatures. Bow ties are cool, Paranor. So Fenrig, I actually have a shirt that says "Not that kind of a doctor," that I love because it can be read in so many different ways. And I was really sad when I was at Disneyland. They had a shirt, but it was only in children's sizes, that said, "I'm a doctor," and it had the dwarf doctor from the Seven Dwarfs movie. And I really wanted the shirt. And if they ever make it for adults, I'm totally buying it. Because I'm not that kind of a doctor either, but I will own that particular shirt. I love your comment, Susie. That's all I'm going to say. Okay. Yes, Paranor, that is your question. The final details may be lost to apply to Earth. Yes, so we may not get the details we need on why things are changing internal to the sun from the external observations that are being made by Parker. So we just need to wait and see. We don't know. You're hitting all of the I don't know. Let me give you speculation questions today. Paranor, I now want a shirt that also says I weigh the same as a duck. Okay, I think I may have the most scientifically literate chat on Twitch. I love all of you guys. And I think that's the end of the show. So that's all I've got. That's all I've got. I'll be back tomorrow at 1 p.m. Eastern, at 10 a.m. Pacific, 6 p.m. London time. And who knows what news we will have? Well, we know one story. We will be discussing the comet found by Tess. Now, as always, CosmoQuest on Twitch is part of CosmoQuest.org, where we invite you to help us do science. So go use your scientific, knowledgeable brains to, well, help us explore other worlds and our own planet Earth. It's all available at CosmoQuest.org, just to say the URL one more time. CosmoQuest.org is a multi-institutional collaboration led out of the Astronomical Society of the Pacific and includes partners you see here on, well, this channel, including the Planetary Science Institute and Youngstown State University. We're working with several other institutes as well, and all of them are listed on our website. So check it out. Give us a follow here on Twitch to be alerted when every single, well, stream goes live. And we are sustained by you. Every subscription really helps, and every bit really matters. So thank you. Wherever you are in the world, have a wonderful morning, evening, or afternoon. And remember to go outside and look up. Unless you're getting rained on, or there's less interesting just plain old clouds, you should have a spectacular view of Mars and Saturn. So I'll see y'all on the other side. Bye-bye.